Excellent. This is exciting. We're going to do a
Yeah.
pre-college program webinar about the engineering and coding programs. And I think, it's typical standard starting of waiting for people to filter in and fill up the attendees. I see the numbers going up, which is exciting. So while we're waiting, I noticed that there's an elephant there in the background of this slide.
Jumbo.
Jumbo the elephant. That's right. That's the Tufts mascot is Jumbo the elephant. And our sports teams and our undergrads and our alums all proudly call ourselves the Jumbos here at Tufts University.
He makes a great mascot. We make little jumbo tchotchkes to give to people. He's a good one.
Yeah,
But I'm
the other thing I like about having Jumbo the elephant as the mascot of Tufts University is the sort of uniqueness, right? You don't run into a lot of other universities that have an elephant as their mascot. The full history is actually back in the 1800s. Barnum and Bailey gave a bunch of money to the university, and that was one of the ways that we
and
recognize that.
and the
So.
actual elephant, right?
And
Didn't
the actual elephant, yeah. So
he-
Jumbo the elephant, a real elephant. Actually, what's crazy is Jumbo the elephant was named Jumbo the elephant after the Kenyan word jambe. And because Jumbo the elephant was so big, the word jumbo became associated with big. And
He
so
didn't
it's
tell
actually,
us that
yeah,
in
it
the
actually comes
orientation.
that way. He was one of the largest elephants around at the time, was actually in the London Zoo for a long time before Barnum brought him to the US and toured around with Jumbo the elephant. Um,
Jumbo.
and
All
when
right.
when Jumbo passed, and they did a taxidermy job, it was the largest taxidermy job that had ever been done because Jumbo was such a large elephant at the time. Anyway,
Yep. And then he caught on fire, and now he's in a peanut butter jar.
there's even more more
That's
history there.
we can get
Uh,
going.
Perhaps we could kick it off.
We can, thank you. So hello, everyone, and welcome to our summer 2024 Tufts Engineering and Coding Pre-College Programs live Q&A. I'm Lauren Barry, University College Partnership Development Director, and along with my colleagues, we're excited to take you through tonight's overview of some of our summer programs. We hope tonight's session will help you learn more about our academically challenging and uniquely rewarding summer programs, including coding, engineering design lab, engineering investigations, and our newest program, engineering with artificial intelligence. Not only do we have a lot of great information for you tonight, but we're also looking forward to letting you drive the second half of the session by asking questions of our team members. As we talk through each of the programs tonight, please feel free to enter any questions in the Q&A section, and we'll keep track to make sure we answer all of your questions following the overview. With that, let's get started and meet the rest of the team for tonight's session.
Hi, everyone. My name is Maggie Tiano. I am a program administrator with Tufts Pre-College Programs. You'll probably see my name if you've sent us an email. I'm in the inbox answering all your questions that we have. Tonight, I will be presenting on the Coding Academy, as our program lead will not be able to make it with us today. So if there are any specific content questions, we'll try my best to answer. If not, you can definitely connect with us later on for more content-specific questions and answers.
Excellent. And my name is Ethan Danahy. I'm a professor here at Tufts University in the School of Engineering, and I'm a instructor of one of the engineering programs. But it turns out that historically, I've also been an instructor of the other two engineering programs. So I have a little bit of experience across all three. And so I'm here representing those, and I'll be able to give an overview of the three engineering programs as well as answer any questions about the format or style or anything about that. And so, yeah, leveraging that Zoom Q&A will be the best way to get the communication back and forth with the team. Oh, and we're going right in. All right, so here we go. So here's the engineering program leads, the sort of instructors for the three engineering programs. So today we're covering three engineering, and then the coding one, which we'll cover at the end. So again, you'll hear this over and over again, but there's the engineering investigations, engineering design lab, and engineering with artificial intelligence. And so because they can't be here, I'm going to also introduce Chelsea and Jennifer, who are the other leads. So starting left to right, Dr. Chelsea Andrews. So all three of us are research professors here at Tufts University. We actually sort of coincidentally all work together within the same group. It's called the Center for Engineering Education and Outreach, and I can describe a little bit more of that. But we all come with a very strong passion for engineering education, which is how do we teach engineering? How do we communicate engineering topics? How do we bring people along that journey of starting as early engineers, not really knowing what they're doing, and then leading them through their engineering curriculum and preparing them for to become an engineer or an academic or whatever it might be their destiny. So Chelsea studied civil engineering as an undergrad at MIT, and then for her PhD, she actually was here at Tufts and studied engineering education. So took both her technical expertise in the background and then got a formal education in engineering education, studying how students learn engineering and thinking about what are the supports and needs that they have. In particular, her PhD was around looking at failure in engineering education. Basically, when students are doing a project and something doesn't go right, how do you recover from that? How do you bounce back? In the field of engineering, we don't want everything to go perfectly smooth. We want to wrestle with and run into obstacles because that's where you really get that good learning from, is if you try something out and it doesn't work, that's where you actually do a lot of the learning. And her studying was in a classroom. How do teachers support that? How do students recover from that? How do you stay resilient? How do you stay optimistic and keep going through the engineering process as you're studying that? So she brings both her strong background in engineering and her expertise in engineering education to her program. And she is the lead instructor of engineering investigations, which we'll talk about in a few slides. In the middle there is Dr. Jennifer Cross. She did her undergrad at Olin College here in Massachusetts, but for graduate school went down to Carnegie Mellon where she did robotics. So she got her PhD in robotics from Carnegie Mellon. So she has a wealth of information about the field of robotics. And then for her PhD dissertation, she did educational robotics. So thinking specifically about the field of robotics and how we develop new tools and technologies that are accessible to learners who are in the process of learning about robotics. And what you'll see as we talk more about the engineering design lab is that's the focus. The focus is on robots and programming and applying engineering design skills to the sort of robotics field and leveraging robots as means of learning engineering. And so she is also a research professor, does a lot of ed tech development here at Tufts. And then finally on the right is myself, Ethan Danahy. I'm also a research professor. My background is computer science and electrical engineering. I actually went to Tufts University for my undergrad, master's, and PhD, and now I'm a professor here, so a lifer. We were talking during the pre-webinar banter about Jumbo the elephant. So when you get all your degrees here, you're called a triple jumbo is the sort of designation. And now I'm a professor here, and I do research into educational technologies as well, thinking about new software and hardware and different interfaces for teaching and learning. And I will be running the engineering with artificial intelligence program. All three of us actually also teach here at Tufts, and we teach within the first year engineering program. So again, when you're 18, 19, and you come to Tufts for the very first time and you want to be an engineer within the School of Engineering, we have a sequence of courses that you go through, and all three of us teach within that space. So we're very familiar with new to engineering, onboarding students to engineering, as we do that as part of our job here at Tufts. And we're now also all experienced within the high school space, in the pre-college space of working with high school students who are doing engineering as well. So bringing both our past expertise, our own current research interests, our current teaching, and bringing all of that together into these engineering programs that we've created in partnership with the pre-college programs at Tufts.
Amazing. Thank you, Ethan. And I think we should make a new designation, especially for you, that's like some super jumbo when you
Yeah.
3 degrees plus you teach here, you get max jumbo.
There you go.
So for tonight's agenda, the leads for each program will provide an overview of the program itself. We'll then walk you through the application process and end with a live Q&A. So just a reminder to please put any questions you have in the little Q&A feature, and we'll answer them during that portion of tonight. First up is our engineering investigations program. So take it away again, Ethan.
Yep, you're going to hear a lot from me tonight as I'm covering all the engineering programs. But I'm very excited and passionate about all of these. So again, there's 3 programs we're going to cover. The first one is called Engineering Investigations. The 3 engineering programs run twice during the summer in this sort of session 1, and then again, we repeat the entire program for session 2. Each session is 2 weeks long, and it's this Monday through Friday, 9 to 5, pretty intense academic program during the day. If you're a residential student, you'll stay here in the dorms overnight, over the weekends, and there's plenty of other sort of social activities that happen. For the academic programs, which is what I'm in charge of and we'll sort of talk about, we do those Monday through Friday, 9 to 5. And then we repeat the session 1, we repeat it again in session 2. So depending on your schedules and vacations and all of those sorts of things, you can pick the one that sort of works best for you. So 2 weeks intensive program where we don't expect you coming in with anything, and then we lead you through the whole process and end with a sort of a final project showcase. So engineering investigations, the real philosophy here is the breadth. Is what is engineering? I'm good at math and science in high school, and I'm interested. I've been told, hey, you should check out this engineering thing, but I don't really know what it is. This is a chance for you to sort of explore that. So it's a breadth across multiple disciplines of the fields of engineering. Now, engineering has many, many, many different fields, and so we can't possibly cover them all, but we hit a nice breadth where we're sort of exposing students to a wide variety of engineering, and especially focusing on some of the fundamentals of engineering, like the engineering design process, engineering skills, thinking like an engineer, approaching problems like an engineer, to give you a sense of what is engineering. And we do all of that through hands-on project-based learning. That's a philosophy that we hold true across all of our programs. So you will certainly not just be quote unquote sitting in lecture the whole time. You will be doing, and that's a trademark and a philosophy that we have for sure here. So the engineering investigations is about the breadth. We also make sure we talk about things that are not just discipline specific, but things like engineering ethics and these ideas around social justice. All 3 of us as instructors also bring that into our other teaching. We believe very, very strongly in preparing engineers, not just from a technical sense, but to play a role as an engineer in society, and thinking very carefully about the engineering decisions that they make and the impact that will have on the products they make, on society, on people and the environment and everything else, the world as it goes, as things that we create go out. All programs, so you'll hear this over and over again, but have this opportunity to learn from Tufts faculty and industry experts. So engineering investigations, engineering design lab, and the artificial intelligence will have sort of daily seminars, sort of interactive panel discussions where we bring in either Tufts faculty who are working in the particular fields, or we'll tap into the industry experts. The beauty of Tufts University being here in the Boston area means that we can tap into our wide network of colleagues that are working at startups and other industries here in the Boston area, and have them come in and share their work, their experiences with our students. So the engineering investigations has a daily seminar for the first 8 days, I think it is, where for an hour, we bring in either a faculty or an industry person to share their experiences and do some Q&A with the students as well. Again, this idea of hands-on project-based learning, tackling real-world problems, will jump between a variety of topics from civil engineering and doing bridge design to environmental engineering and protecting storm drains from particulates. We'll get in various labs. We've done motion tracking in our motion tracking lab to study the physics of air flight. We will do get into an electronics lab and learn about some circuitry and some things like that. And we, again, all of these programs will apply the engineering design process and be thinking about those things as well. The program is designed to hit a lot of topics quickly, again, because it's a breadth. And then as the program gets into that second week, we'll start to transition towards a final project. And then what happens here is students work in small self-selected groups around topics that they're interested in. So there's a process that we go through where students reflect on the topics that we've shown thus far, pick things that they're interested in, real world problems they're interested in solving. We match people up into small groups, and then they have a few days at the end of the program to actually solve or prototype a solution. Obviously, they pick big things that can't be solved in 2 days, but think about the process, develop prototypes, do research, sort of early analysis into that, and then end with a final presentation, a final showcase on the last day. And that one actually we make open to the public, but mostly to parents who are there to pick up their kids, or to other members of the Tufts community. So we'll have grad students and faculty and staff sort of cycle through and check out the awesome projects that these high schoolers have been sort of working on. So one of the big focuses or belief systems that we have is also on developing a portfolio. So all of our engineering programs will have students documenting their work all the way through, so that you come out with this really strong digital portfolio of the things that I explored while I was part of that program, both the smaller projects and then definitely that final project at the end. All right, so I covered academics, Monday through Friday, 2 weeks, sort of giving a sense of the breadth. Stylistic, we jump between topics, we invite in people who are experts in those areas to help share that, and then build up towards a final project with the final showcase. Think that covers the majority of engineering investigations. So you would like me to move on to Engineering Design Lab. So what we talk about, so while engineering investigations is that breadth, with the Engineering Design Lab, it gets a little bit more focused, and this one is in particular on coding and robotics. For both engineering investigations, we assume no prior experience. You can come in cold and be ready to go. Similarly, with Engineering Design Lab, we do not have a prerequisite for that. So you can come in without any robotics experience, without any programming experience, no prior experience necessary. We will lead students through that entire process. I say robotics, but it's a bit more than that. It's a larger than that, because of course we still are exposing people to the engineering fields. We also do a lot of fabrication. So we spend time in the makerspace here on campus. And actually that's what this photo is, our students working within our on-campus makerspace. And so we also include digital and manual fabrication as part of this program. So students learn CAD. We introduce them to Onshape, which is a computer-aided design program. We have them do digital designs. We 3D print those, we laser cut those, and we also have students engage in woodworking to get that experience of actually doing some woodworking as well, because that's one thing that we've seen as students want to fabricate something that they often don't have prior experience doing a lot of woodworking stuff. So that's on the fabrication side. And then back in the classrooms, we'll introduce students to the field of robotics, the components of how robots work, and then actually making sure students engage in that. We do mini Intro to Python lessons to get them up to speed in case they have no prior programming experience. And then we have them learning about motors and sensors and navigation and locomotion and some control theory. And then we have opportunities to explore deeper into other topics such as computer vision and image recognition, image processing, advanced control theory, a little bit with doing APIs and communication with other external services, cloud computing, as well as Jen teaches some machine learning here as well, so she can bring some simple machine learning and AI to that course as well. It follows a similar kind of format in that every day is this sort of academics that gets that progressively builds on itself over those first sort of week and a half. Also paired with that are the seminars, where we have industry experts and Tufts faculty coming in and sharing their own research, often in the field of robotics or engineering more generally. And then it builds up to the point of reaching a final project. And it goes through the exact same process that engineering investigations does, that students express ideas, thoughts around creative projects that they want to take on. We find small groups that can work together, like these students here, in order to solve a project. And then we spend the last few days fabricating and creating prototype solutions towards solving some big problem and ending with a showcase. We actually pair the showcase together so that both programs are showcasing together in our big open atrium area. So what's really cool about that is that you will bump into students from the program. Either if you're residential, you'll be in the dorms together, or just as the programs sort of pass each other in the hallways, and you'll hear about and you'll get to see a little bit from each program, and then see really the final projects that they create at the end of the session. Same philosophies of hands-on project-based learning, diving deep into it, applying engineering theory to the real-world problems, all of that bits and pieces. All right, I think that covers Engineering Design Lab. And then we have our newest program. And so, as I've said, I've had experience both teaching Engineering Design Lab and Engineering Investigations. And now I'm in the process of designing and will be the lead instructor for the Engineering with Artificial Intelligence. And so we, of course, are super excited about this, as most of the world is. This has become a topic that is on a lot of people's minds, both from industry's mind of what is the response to AI, how is artificial intelligence, machine learning, and all of these tools being incorporated into the real world. But of course, in education, we also are thinking very hard about those kinds of concepts. And as somebody who both develops educational technologies, is an engineer myself, developing new tools, and is an instructor, I've been thinking a lot about AI and working in this space, both professionally as a teacher and professionally as a researcher. And so here at Tufts, I teach an Intro to Engineering Design course in the fall. I just finished it this past fall, where I completely redesigned it all with AI. So infusing artificial intelligence in all kinds of different ways, both from the concept of teaching my students about AI, but also using various AI platforms to sort of assist with the both the learning and the development of solutions, of engineering solutions. So very excited about this, and sort of exploring it. When I talk about AI in education, there's sort of two perspectives that we are approaching it from. One is learning about AI. So what is AI? What is the history of artificial intelligence? What's the subtopic of machine learning, and what's the relationship between those two things? What are long established machine learning algorithms, right? AI has been around for more than 50 years, even if we've only been talking about it over the last year in a heightened sense. And so what's that history? What are some simple machine learning algorithms? What are more complex ones? How do they sort of build on each other? And then, of course, talking about sort of the newer space of generative AI, large language models, neural networks, and sort of thinking about the what's dominating the current sort of news media. And so thinking about that history, understanding what is AI, how does it work, and these types of things. And then on top of that, using AI to learn, or using AI to do engineering design. So there's those two sides. What is it? And then how do I use it? And then what's interesting is, of course, the intersection of the two, where I am doing both of those simultaneously. I'm actually using AI to learn about AI. And so we've also been sort of looking at how that process is. How do I actually appropriately use something like generative AI as means of generating code and algorithms to actually do machine learning on data sets and things like that. So this course will hit on all of that, and we're going to package all of that together into this. Because we are trying to do a lot in a very short period of time, it's again these two sessions each 2 weeks. This one does have a prerequisite. So we need students to have some experience with coding coming in, so that we can hit the ground running and not start from ground zero. What we do not care about is what language. We'll be doing a lot of programming in Python, but what we have found is that if you have taken a class in Java, or have prior experience in another language, that often that translates very well. And we've because of our own teaching and having done this in the past, we're able to get you up to speed into the syntax of Python as long as you come in with some prior experience. And so as part of the application process, we actually do look at your prior experience. We want to make sure that you have done things like variables and functions and loops and conditionals, and sort of have a sense of how text-based programming works. If you've only done Scratch, not quite enough. If you've only done HTML, which is a markup language, not technically a programming language, or something like that, not quite enough. And we can answer some of the questions as to what constitutes enough. But again, we want to have that prerequisite to make sure students hit the ground running. Once we get in, we're going to cover all of those things I said, both the sort of history of AI and machine learning, simple to complex algorithms, and then interacting with artificial intelligence systems, especially generative AI, which is the hot topic right now. And we'll cover all of that over that, again, first week and a half-ish, sort of hitting on a variety of topics. We'll be bringing in faculty and industry experts again, talk about what is their research into AI, how is that affecting industry, what are people wrestling with, what are some of the ethical considerations. There's a lot of those associated with AI and as an emerging field. So we'll be covering all of that. As we build up those skills, we'll then similarly at the end of the program transition to final projects, where we want students to think about big problems and think about how AI could be used to solve those, either artificial intelligence, machine learning, or some other related process. And then we'll help students actually start to prototype and implement those types of solutions towards a final presentation. We'll do it slightly different than the other programs. The other programs are a showcase where people stand in front of posters with a physical thing and sort of talk, and people filter around and talk about what they're doing. In the artificial intelligence, we'll actually have students make little presentations that will actually be shown up on the screen during a separate final presentation time. But very similar in that we'll be doing group work, we'll be doing hands-on, lots of coding, and then thinking about the implications of AI on the real world. So both in terms of solving problems and what are the associated things to consider as this technology sort of becomes prevalent in the world. Let's see. Anything else? Covered background, some of the topics we'll be covering, the general flow, and then final showcase with daily seminars as well. Okay, I think I got those. I see a couple questions before we move on to the coding. Do you want me to hit on some of those?
Sure. Yeah, we can pause for a second and answer those.
Great. So I see a question that says, do you touch on city planning for engineering in the engineering investigations one? We do not say city planning specifically. The civil engineering that we sort of do is around some bridge design, where we actually do some simulation and modeling of various bridge types, also taking into consideration material type, cost, and some things like that, but not specifically city planning. I also mentioned our storm drain protection activity that we do. That one is, again, sort of hyper localized, not in the larger city planning. So that's not a topic that we sort of touch on. Is there differentiated learning in these engineering programs? So we support all kinds of learners, both in terms of, I think this one's getting at if you come in with prior experience versus if you come in as a new programmer. We definitely do support that. We get a wide range of students coming into both engineering investigations, but also engineering design lab with prior experience. Some students who have never coded before, some students who have done first robotics and have that kind of prior experience. So, and then everything in between. The techniques that we use in order to support everyone equally is, one, a lot of self-guided stuff. So we have both a lead instructor as well as 4 teaching assistants that support these programs. And so with a lot of people in the room, we're able to subdivide. And then also students are able to do self-guided through some of our curriculums with support in the room support. Second is we definitely start to split people up, and so that we can divide and conquer and say, all right, we notice that this group is chasing this idea and has this prior experience, we're going to send you off with this TA and head you in this direction. These ones need a little bit more background in order to get up to speed. We're going to head in this direction. We're also good at taking your ideas of like final projects. Oh, I want to make this crazy thing. Yes, but we only have 48 hours and your skills aren't quite there yet. So let's do this smaller sub part of that, which we believe is doable in order to prove a point or create a valid prototype. And so we will adjust things appropriately based on where people are at. So there is sort of a differentiated type of thing. We also, of course, as educators, are cognizant of that students come in with different preferences towards learning. And so we also present things in multiple ways. We have text and written ways of doing it. We lecture. We have one-on-one support when we're working with a TA or doing these things. So students can access information in a multitude of ways if one way in particular isn't working for you. Another question was if we touch on nuclear power in the engineering investigations. We do not. So that is not one of the departments here at Tufts. That is not a research area at Tufts. And so because it's not in our expertise, we did not include that in the engineering investigation. So that is in the breadth of what we do, one of the things that did not fit. So we do not have that.
Oh, sorry, Ethan, to just to interject for the next question about candidates for these programs we decided and when.
Right.
We do have a slide coming up that explains the whole application process. So if you want to just hang on to that question.
Great. Yeah, I was going to skip over and get to the next one that asks about a comparison between the three engineering programs and is one more hands-on or not hands-on. The philosophy of all three instructors, especially because we sort of come from this similar research background, is that we do a lot of hands-on all the time. So actually all of them are very hands-on, and I could not say that one would be more hands-on or less hands-on than another one. All of them will include a little bit of lecture because that's one way to get through a lot of content quickly, but all of that lecture is also supported by interactive hands-on activities. So we try to include that as much as possible. No one can survive a Monday through Friday 9 to 5 program that's just being talked at. And so, yes, we include lots of hands-on in all of those, and we're always trying to do projects that reinforce those ideas. So all three programs will include a lot of doing type of thing. For the AI program, one person asked, should the students bring their own laptop to use during the program? This is actually true across all programs. So we leverage technology as best we can. As you get as you apply for it, get accepted into, and the time of the start of the program comes, we will send more information about what to bring. And BYO technology is one of the things that we will recommend. That said, we also can support people in various ways if there's some logistical thing on a case-by-case basis. But typically, yes, everyone should bring their laptop for all three programs, because for engineering design lab, we use the laptops to connect up to the robots in order to program them. For engineering investigations, we do a lot of digital portfolio making, a lot of on computer work. We make presentations, we do research, we generate ideas, we access various tools and technologies. And then for artificial intelligence as well, you will be needing to access things on a laptop. One thing that we have found that does not work super well is just an iPad, because especially with these programs that need programming, you often need a keyboard. What does work is an iPad with a keyboard. But again, that's a subtle sort of difference. But yes, you should BYO technology.
Great. And Ethan, would you mind if we just paused and did the coding one, just in case anybody's pressed for time, and then
Right.
we can loop back
Sounds
and
good.
answer the questions that are in the queue?
Love it.
Awesome.
Great. Thanks, Ethan. Thanks, Lauren. So we're going to switch gears a little bit and talk about our Coding Academy program for this year. So this is a residential commuter program that will run from July 21st to August 2nd. Students will work over the 2 weeks to gain proficiency in specifically Python and potential to work with other coding languages. This program is open to students who are beginner coders and to coders of different and higher skill levels. So as you're applying to our program and being accepted, students will be asked to complete a pre-program assessment that will help us break out students into different tracks according to coding experience. So based on your assessment and your answers, students will be placed into their track. We'll be splitting students into 3 tracks this year, more of a beginner, intermediate, and a more advanced level. So you have opportunities to work with your peers that are on similar levels of coding experience as you are. If students are finding that the level that they've been placed into needs to be shifted, either down a level or maybe perhaps placed into a more advanced section, there will be opportunities to adjust this within our program as your students arrive to campus. Students will have specific lectures based on their experience level cohort. However, we'll have opportunities to work, connect, and mingle with peers at all levels in our afternoon sessions. And again, all groups will join together in the afternoon for tech treks around Boston and larger group activities. In the past, students have had opportunities to hear from visiting lecturers and professional coders in their respective fields, as well as field trips to companies in this Boston Tech hub that we're a part of over on the Medford Cambridge side of the city. Students will also have the opportunity to use the skills learned in this program through hands-on interactive activities led by field experts that are coming to Tufts. So by the end of the program, our students will plan, create, and pitch their own custom designs using the coding skills that they've learned over the past 2 weeks. In previous years, this has included students building websites, apps, and interactive games and video games with the help and encouragement of our staff, as well as their peers working together, working individually, and having opportunities to see what that's like. And these final presentations will be presented at the closing ceremonies to parents, family, and friends. Overall, the students will be able to earn a Tufts matriculated credit for this program. So matriculated meaning a credit that you've earned before coming to a 4-year institution. And develop an in-demand skill such as coding and learn how to market these skills with students from all around the world. And that's what I have on those. I'll pass it back to you, Lauren.
Awesome. Thank you, Maggie. Okay, before we get into the rest of the Q&A, let's get into one of the most important steps in our process, getting ready for the application. So we had a question about this. Hopefully this answers it. So first things first, you will need to head to our application landing page to register for your account. You can find that link on all of our program websites where you see the Apply Now button. So you click that and it'll take you to the registration page. Once you've registered, you can log into the system and start your application. You'll put in some basic personal info, family information, and then you'll select your program. To supplement your application, you'll be asked to provide contact information for a recommender and a school official who will upload your transcript and recommendation letter. Some programs may also require additional application materials such as lab preferences, a brief personal statement, or level of experience in the particular content area. So I think Ethan mentioned this as something for AI as an example. As part of your application, your parents will also need to fill out the parent permission form, and your recommender and school official will be prompted to upload your letter of recommendation and your transcript respectively. Once we receive these materials, we will return your admissions decision within 10 business days. Upon admission, you'll be asked to submit your deposit and some enrollment forms, followed by full payment. And just like that, you'll be ready to study with Tufts. So I will now turn it back to the rest of the Q&A portion. So I think we had one, hopefully was answered. So I think the next one we've got going on now is the what is the ideal grade, high school grade year for EDL? Is the 9th grade summer going into 10th grade too soon? Do you need some level of physics and math classes taken, although there's no prerequisite?
Yeah, great question. So so the programs, and correct me please if I get something wrong, but the programs are open to rising 10th graders up through those who actually just graduated. So you might be actually after 12th grade. And so it's open to that range. And so we mean that. So yes, it's open to that range. Historically, what we have found is sort of a bellish curve, right? Where there's sort of fewer rising 10th graders, there's fewer just graduated, and a lot more are sort of in that rising junior, rising senior in high school type of thing. So so going into 10th grade is not too soon, That said, you will be on the younger age of the overall group. That said, it is not unacceptable. For EDL and EI, we again assume no prerequisite going in, and so there is not some level of physics or math that are sort of required, and we will adjust sort of appropriately. So if you know anything about controls in control theory, there's different ways of doing a control theory for a robot, and there might be something like a proportional control or a bang-bang controller. Those actually both have sort of different mathematical bases. And so if you're not up to the speed of having to do one of them, we'll either slowly work you through and try to explain it to you, or we'll focus on another one and we'll do that differentiated type of thing as we're going along. So we've done this before with students of all ages, with all backgrounds, and we've been able to tailor it to fit what you need. So again, not too young, but do be aware that in that bell curve, most people will be older, but not unacceptable.
And with that, I will say that is a little similar to the Coding Academy. Again, this is a Coding Academy is open to students who are extremely beginner of coding. So you just have an interest in coding, maybe little to no experience, to a little bit more experience. So you don't necessarily have had to take the math course or the science course or a computer science course in your high school to participate in the program.
Right. The next question I see there is around thinking about CAD. And so CAD is used both in engineering investigations and in engineering design lab. And the program that we use is Onshape. We use this for a couple reasons. One, it actually is a full-featured industrial application. So you're using things that are real world and are used by industry. Two, it is a web-based piece of software so that it works on all computers without having to install something special and go through that. And three, we already have tutorials and lessons and activities already developed, mostly because we also use that here at Tufts as one of the CAD programs. So we do not use SolidWorks. We do use Onshape. That said, the concepts are very similar. A lot of these advanced CAD programs that are used in an industrial context all have basically the same bunch of features. And so, yes, the buttons will be in slightly different places, or they might consider something different. But I believe that that using Onshape will prep you appropriately for using something like SolidWorks. You'd have to do a little bit of converting from interface A to B. But we do use Onshape. We don't use something like, say, Tinkercad, which is a very much a middle school or K-12 application for doing modeling. We do use Onshape, which is full featured. And again, we work students through from having never done CAD before, intro to the interface, and actually designing and then fabricating based on that. Another question I see is biomedical engineering touched on in engineering investigations? So again, engineering investigations has breadth. Biomedical is one of the topics that we cover. That said, we cover it in a couple different ways. One way is that it may come up in some of our client-centered design. So biomedical, of course, is a large field, like many of these fields, and has a lot of sub-disciplines. But as we focus on clients and thinking about design for clients, often biomedical engineering comes up as a field and as a topic and as one of the sort of sub things that we talk about. The second thing that we do is there's a very hot topic area of research that's happening here at Tufts right now that sits within biomedical engineering, which is cellular agriculture, which is the research name given to lab-grown meat. And so we actually have a module on cellular agriculture that falls under our biomedical engineering discipline. That's where it sits here at Tufts, and that's where we sort of fulfill that. And so we learn about lab-grown meat, cellular agriculture, and we have an ethical discussion about it, and we have some other conversations, and we hear from researchers that are in that field as well. So those are the two ways that we talk about biomedical engineering. Next thing that I saw was back on the topic of laptops. There was a question as to whether Mac or PC or Chromebook, and if there's a Does it matter? To me, it doesn't really matter because a lot of what we do is web-based. So we try to leverage web technologies as much as possible because we don't have to worry about whether it's a Mac or a PC or a Chromebook. And it allows us to open a browser, access online software without having to do any local installs. Also, that means that we don't have to worry about, does the student have permission to install things? Do they have an admin account? Are they appropriately all of that is we found to be headaches. Sometimes there would maybe are slight exceptions to that. And if a student can install something, they do. And if they can't, we find another solution, working groups, or provide tools and technology. So to us, it doesn't matter whether it's a Mac, PC, or Chromebook. We can make it work in all of those.
And similar to the coding program, there's no preference of what type of computer. Like Ethan had mentioned before, we would just prefer an actual computer to a tablet or an iPad. So just making sure that it's a computer rather than a tablet. But those kinds of devices, it doesn't typically matter. We don't rank one higher than the other. The next question I see here is, what kind of weekend activities are there? And can you please share some examples? And I can kind of tie into this. I see a second question about residential students and what type of activities are there to engage when you're not on campus. So maybe not necessarily weekend, but out of class. So we have a staff of residential coordinators and residential directors who are excited for our students to come to campus and live with us this summer. And part of that is including an array of activities for our residential students to participate in. So in the evening activities during the week, after your students have been in their classes and their programs all day, these activities happen more close to home. So in the past, it's been painting night, organizing soccer games on the residential quad that our students live in, movie nights and whatnot. However, on the weekends, there are more trips out to different areas of Boston. So in the past, we've done a trip to Godzilla, walking on the Freedom Trail in Boston, as well as a trip to Six Flags in different areas in the Boston. So part of this is our residential coordinators also like to connect with your students, see what your students are interested in. So they're working really hard to make sure we have exciting activities to keep your students engaged after the classroom and program hours.
Can I say one thing, which is what we have found is that the academic part is pretty intense, right? Because it's Monday through Friday, 9 to 4, 9 to 5, whatever it might be. And so my philosophy in terms of that is that there's not homework, right? So what I want you to do as a student is to leave the academics in the classroom and actually make sure that you're enjoying some of that social time and interactions with other people as part of the residential program. So we try to keep all of the academic stuff happening in the classroom during the daytime, and then leaving that time for that recharging the batteries, mentally recovering, and doing things like that. Maggie, the two things that maybe you want to touch on is one, parental permission for going off of campus would be one thing, and then two is access to other Tufts resources. I'm thinking specifically like the gym and things like that that your ID can give you.
Yeah, that's absolutely a great point to touch on, Ethan. So our students do have access to the different facilities on campus. So if you are someone who maybe are very excited about your project and you'd like to do a little extra work after school or whatnot, you can have access to the library, the databases that Tufts University offers, as well as access to our fitness center, our fields. A lot of our students like to use the gym on campus while they're here, access to the dining halls on campus, and the student rec center as well. So you do get this kind of feel of what it would be like to be a Tufts student on campus. So you're living with us, you get to walk to the dining hall, get to walk to the different facilities on campus, as well as there is an opportunity for students to go off campus with a signed off campus permission form. So in groups, students would be able to walk around the Medford, Tufts, Somerville, Boston area, making sure that they're continually checking in with our supervisors and our residential coordinators, and following the rules as stated in our code of conduct, as well as connecting with our team. But students do get that opportunity to truly see what it's like, that if they were a student on Tufts campus, what it would be like to walk the 8 minutes to Davis Square and go see a movie and eat dinner with your friends, or there's a JP Licks, which is ice cream around here in Boston that a lot of our students like to go to, and just see what that's like. So there definitely is a little bit of freedom there, but we do ensure our safety for our students and our parents' needs at home. So that's a great point, Ethan. Thank you for bringing that up.
Thank you both. So I think the next couple questions I can take. So the next one is, how do you apply for scholarships for residential students? So we do offer basically need-based financial aid. There will be a question in the application as to whether or not you intend to apply for it. That aid is first come, first serve, and is based on your demonstrated needs. So you would include information about like family income and things like that. And then you receive a decision on your aid generally within about 2 weeks of applying. And so that you would find out, around about the time that you would need to do the deposit in case that's a limiting factor. So then the other one is, do students ever do more than one program in a single summer? Do they submit more than one application, and would they stay in the dorms the weekend between the 2 sessions? The answer is yes. We definitely have students who do more than one. You would submit more than one application, so you would basically do the same process twice. And then you could stay in the dorms the weekend between the 2 sessions. We have had students do this in prior summers, so not an uncommon thing.
It's not uncommon, but it's definitely not common, right? There's I remember a student last year that did both engineering programs. So it's a little bit unique, but definitely have had people do it, and they've gotten a lot out of it. There is a couple things that we've repeated, right? So some of our orientation stuff, some of our rules and regulations, right? There's, yeah, you heard this 2 weeks ago as we're going through it, but again, the programs are drastically different enough that there's plenty to get out of it for sure.
Yeah, and we've also had students do, I think we had one last year who did engineering design lab, and then they did our Tough Summer Accelerator actually right after. So you could do 2 wholly different programs.
Which would be totally different. Yep, exactly.
And I mean, you might still hear some orientation stuff that's similar in the back-to-back weeks, but yeah, totally doable. Cool. So we have a couple other questions. Ethan, I want to make sure we get to the one that says, would you get experience that would be helpful for a robotics team and engineering design lab? And if so, what would be the benefit to that?
Would you get experience that would be helpful for a robotics team? So certainly you would get experience into the field of robotics. There's a lot of different robotics competitions out there, and they use particular platforms, and they have certain rules and regulations, right? So FIRST has a whole competition booklet and all the rules and regulations. We are not in that space, so that is not what we're prepping you for. But we would certainly get into ideas around communication and collaboration, and taking large problems and subdividing them and then working through, and then some of the theory of robotics. We don't use a FIRST-based or other robotics team platform. We use something called the GoPyGo, which is a educational robot platform, but it has all of the same concepts built into it: inputs, outputs, sensors, processing, and how do you bring all of that together into a package. So you'll certainly get skills there, but it's not a program that's targeted towards prepping people specifically for that. It's a little bit more generalized.
Great, thank you. Oh, sorry, anything else on the robotics question?
Nope.
So in terms of the acceptance rate, it's less about the acceptance rate and more about having a strong application overall. So because it's rolling admission, we do look at each application sort of on its own merits. And so the aim of the game here is to have a strong transcript, strong recommendation letters, and the statement that you write, is well written, and that you're really advertising your strengths to be a part of the program. So less on strict acceptance rate and more on those things. Ethan, I don't have the demographic breakdown handy for the engineering programs.
I also do not. That's a great question. So, but the class size I can answer for engineering.
Yep.
So we specifically have 40 students. We've capped it at 40 students across
Mhm.
all three programs. So 40 students in engineering investigations, 40 students in engineering design lab, and 40 students in AI. It has filled every single time, so it will be 40 students. 40 students is this really nice number where you have a cohort. We get to know everyone with with 4 TAs and a lead instructor. It's a good ratio, and it doesn't get too big, and so there becomes this sort of small community. And so we've limited it at 40 for exactly that reason. I don't have the male-female breakdown, but I have to say that there's good representations on both sides of the fence there, and so we have plenty of women coming to our engineering programs, and we are very thoughtful in the ways that we support all types of learners. That is one very strong passion of all three instructors, is thinking about how people come into engineering, how they're supported in the field of engineering, and making sure that they see representation and are feel included in the field. So.
Awesome, thank you. So I know we only have a couple of minutes left, so if there are any last questions, we could take maybe one more. And then if you have more questions, if you wake up tonight and you're like, I didn't ask the thing that's so important to me, you can always reach out to us. We're precollege.tufts.edu. So you can always email us and we can put you in touch with whoever you want to ask questions of. So thank you all again for joining and for all of your great questions. As always, if you think of anything after this call, you can always contact us here. We have all of our contact information up. And please follow us on your favorite social media channels to stay up to date with what is new in pre-college programs at Tufts. Thanks again to everyone for joining tonight. We're looking forward to hopefully meeting you all on campus this summer.
Yeah, thank you so much. It was fun to talk about all this and cover these programs. We're excited about it.
Absolutely. Thank you everyone for joining us.